Here we have a SAT math problem. Okay, let's go with the question. In the triangle above, the length of DB is 4 and the length of CD is 6. What is the area of triangle ACD? Okay, the length of DB over here is 4 and the length of CD is 6, and we have to get the area of the triangle ACD. Okay, to get area of a triangle, we can use a formula that is 1 half times base times height. Okay, here for this triangle ACD, if I want to get the area, I must be knowing the length of the base. The base is the side AD of the triangle, and the height is the side CD of the triangle. I know the height of the triangle ACD, that is 6. I can plug in the 6 for H over here. Okay, if I get the length of the side AD, that is the base of the triangle, I can plug in the value for B over here, and I can get the area of triangle ACD. Okay, how do you have to get the length of the side AD of the triangle? That is, the AD is being as the base of the triangle ACD. For that, let me consider the original triangle ABC over here. Actually, it is a right triangle because for the original triangle ABC, we have right angle at C. And also, there is an altitude drawn from the vertex C to the hypotenuse of the triangle AB. So, because AB is the opposite to the right angle over here, AB is the hypotenuse of the original triangle. Whenever there is an altitude drawn from a vertex to the hypotenuse of a right triangle, the altitude will split up the right triangle into two right triangles. Here this altitude CD splits up the original triangle ABC into two right triangles. One is a triangle ACD and the other one is a right triangle BCD. And both these right triangles, that is right triangle ACD and the right triangle BCD, both these right triangles will be similar to the original right triangle ABC. Okay, now let me compare the right triangle ACD with the original right triangle ABC. That is, I am going to write the similarity statement for these two triangles. Okay, first let me take the vertices from the right triangle ACD. And also one more important thing we can notice, A is a common vertex for the two right triangles, the triangle ACD and the original triangle ABC. Since A is a common vertex for both the triangles, let me write the vertex A in both the triangles, A and A. Now, let me consider the vertex D in the right triangle ACD. At the vertex D, we have right angle over here because CD is the altitude, it's perpendicular to the base. Okay, let me write the vertex D in this right triangle ACD at where we have the right angle. Okay, in the original triangle ABC, let me consider the vertex at where we have the right angle, that is the vertex C. Let me write it. And the third vertex in this right triangle ACD is C. And the third vertex in the original right triangle ABC is just B. Okay, here let me consider the vertex A over here and here. A is a common vertex, so the interior angle measure of the vertex A over here, the interior angle measure of the vertex A over here must be same by reflexive property. And let's consider the second vertex D over here and the second vertex C over here. For this right triangle ACD, we have right angle at the vertex D, and for the original triangle ABC, we have right angle at C. So here we have right angle at the vertex D and right angle at the vertex C. So the two interior angles of this triangle ADC are equal to the two interior angles of the original right triangle ACB. By angle similarity postulate, the triangle ADC is similar to the original triangle ACB. Okay, now let me write the same similarity statement for the right triangle BCD and the original triangle ABC. When I compare the right triangle BCD and the original triangle ABC, we find the vertex B in common. Okay, now let me write the vertex B first in both the triangles. Okay, here vertex B. Okay, now let me consider vertex D in this right triangle BCD because we have right angle at the vertex D. And also in the original triangle, we have to consider the vertex at where we have the right angle, that is C. The third vertex of this triangle BCD is C, and the third vertex for the original triangle is A. Okay, here B is a common vertex for both the triangles, that is the interior angle at the vertex B is same for both the triangles by reflexive property. And we have right angle at the vertex D in this right triangle BCD, and we have right angle at the vertex C in the original triangle. So clearly the two angles of the triangle BCD are equal to the two angles of the original triangle B and C. So by angle similarity postulate, the triangle BDC is similar to the original triangle BCA. Here we have the vertices of the original triangle, and here also we have the vertices of the original triangle, but the vertices of the original triangle are not in the same order. So here we have the vertices in the order ACB, here we have the vertices in the order BCA. Okay, we have to get the vertices here and here in the same order. So now what I'm going to do is I'm going to write the vertices BCA in this order ACB. For that, I have to switch these two vertices B and A. When I switch these two vertices B and A, so here also I have to switch the vertices B and C at the same position. Okay, now let me write it. So when I switch these two vertices, I am getting C, D, B over here. And here, when I switch these two vertices, I am getting A, C, B. Okay, in whatever order we have the vertices of the original triangle over here, in the same order we have the vertices over here. Okay, now let's consider the triangle ADC over here. The triangle ADC is similar to triangle ACB, and here the triangle CDB is similar to the same triangle ACB. Since these two triangles, triangle ADC and triangle CDB, are similar to the same triangle, then these two triangles must be similar. That is, triangle ADC must be similar to triangle CDB. Let me write it over here. Okay, since these two triangles are similar, then the corresponding sides are proportional. That is, the ratios of the corresponding sides must be equal. Okay, now let me take the side AD from the first triangle. The corresponding side in the second triangle is CD. Let me write it. Okay, now let me take the side DC in the first triangle. The corresponding side in the second triangle is DB. Let me write it. Let me take the side AC in the first triangle. The corresponding side in the second triangle is CB. Let me write it. Okay, since these two triangles are similar, the ratios of the corresponding sides must be proportional. Okay, what is the length of AD? Actually, AD is not known. That is what we have to find, because AD is the base of the triangle ACD. Okay, now let's keep AD as it is. And what is the length of CD? CD is given. The length of CD is given. That is 6. We can plug in 6 for this CD. And what is the length of DC? DC and CD, both of them are same. 6 is the length. We can plug in 6 for DC. What is the length of DB? DB is 4. That is given in the question itself. What is the length of AC? And what is the length of CB? For the sides AC and BC, we don't have any information, so we can ignore this ratio. Okay, now let's consider only the first two ratios. Okay, now what we have to do is we have to solve for AD in this equation. Okay, for that, let me multiply both sides of this equation by 6 to get the denominator over here. Then the 6 will cancel out. Okay, here for both 6 and 4, we have the greatest common divisor 2. That is, 2 goes into 4 2 times and 2 goes into 6 3 times. Here 2 goes into 2 1 times and 2 goes into 6 3 times. Then we get AD equals to 3 times 3 is 9. Okay, now I got the length of the side AD of this triangle ACD. That is 9. Actually, AD is the base of the triangle ACD. Okay, for this triangle ACD, now we got the base 9. Already we have the height, that is 6. Okay, now let's get the area of the triangle ACD. Let me write the stuff over here. Area of triangle ACD, that is equal to, the formula is 1 over 2 times base times height. Okay, here 1 over 2 times. So here B is the base of the triangle, that is AD. Its length is 9. We can plug in 9 for base B over here. And the height of the triangle ACD is 6. So we can plug in this 6 for height over here. Okay, here 2 goes into 2 1 times and 2 goes into 6 3 times. Okay, 1 times 9 is 9. 9 times 3 is 27. Okay, I got the area of the triangle ACD, that is 27 square units. We find this 27 in answer choice B. The correct answer choice for this question is B.